Hi, my name is Kimberly Gonzalez.
Hi, my name is Jillian, and our presentation is about evidence of chemical reaction/chemical change.
The founder of chemical reaction is J. Willard Gibbs, who went to school at Yale University, New Haven, CT. He was born in February 11, 1839 in New Haven. In 1863, Yale awarded Gibbs the first American doctor in philosophy and engineering. He died on April 28, 1903 at the age of 64.
Chemical reactions are a process in which the atoms are rearranged into a combination of a molecule. Chemical reaction usually involves a change in appearance. An example, color change, produce a gas, produce a precipitate, and producing light, sound, or heat. Okay, now chemical reaction changes cannot be reversed ever. Chemical change can't be reversed. Some chemical changes are non-reversible change. Chemical change are accompanied by gaining or losing energy.
In chemical reaction, only the atoms present in the reactants can end up in the products. No new atoms are created and no atoms are destroyed. In chemical reaction, reactants connect each other. Bonds between atoms and the reactants are broken, and atoms regain and form new bonds to make the products. Start the video?
Don't start the video, explain that.
Other types of reactions are synthesis and decombination, and substitution are other types of reaction.
Can you tell us, before you click on the link, what does synthesis mean?
Two or more substances combined to make a new compound.
That's synthesis. What is decomposition?
To break apart or be separated from each other.
So that's one compound becoming two new ones. And what's substitution?
Substitution is
when one compound takes the place of another compound.
When one compound takes the place of the other compound.
Now,
video.
The link.
Hi, it's Mr. Anderson, and this is Chemistry Essentials Video 29. It's on synthesis and decomposition reactions. If I were to ask you which of the two reactions you see on the left is a decomposition reaction, the tendency is to choose the rusting railroad car. And the reason why is it looks like it's breaking down. But if you think about it, what is rust? Rust is a combination of iron and oxygen, and so this is actually a synthesis reaction. And so if we ever take atoms and molecules and combine them together to make a new compound, then we've got a synthesis reaction. So what's an example of a decomposition? The breakdown of water into oxygen and hydrogen gas is going to be an example of that. And so if we take atoms or molecules and we combine them together to form a new compound, we call that a synthesis reaction. We're making something. Likewise, if we take a compound and break it down into atoms or molecules, we call that a decomposition reaction. Lots of times that'll generate a little bit of heat. And so synthesis reaction are when we're taking atoms and molecules and combining them together. So let me give you a couple of examples. Let's say we take magnesium, get it a little bit hot, and then allow it to combine with oxygen. It's going to make magnesium oxide. And so when it's done, you're going to have a new solid that's creating. We're taking a solid and a gas, and we're making a new solid out of it. Another example of a synthesis reaction could be the carbonation of water. And so this is me adding a little bit of carbon dioxide to my soda stream at home. And what's going to happen inside there is that the carbon dioxide is going to combine with the water, and it's going to make carbonic acid. So that carbonic acid is going to lower the pH to around 4, and it's going to change the taste of that carbonated beverage. What's decomposition then? It's when we're taking a compound and breaking it down. So here's an example. If we take sodium azide and break it down into sodium metal and nitrogen gas, that'd be a decomposition reaction. So if we have one reactant and two products, it's a good idea that this is probably a decomposition reaction. Where's an example of this actual reaction? Well, this was used in early airbags. And so what you can do is you can put some sodium azide inside the bag right here. It's totally stable, but if you add a little bit of heat to it, so there's an igniter inside there, it's going to quickly break into sodium and nitrogen gas. And that nitrogen gas is going to fill up the bag really quickly. Now you could imagine a bunch of nitrogen in there is not a good thing. That's highly reactive as well. And so they also put chemicals in here that react with the sodium. Another example could be right here. I'm taking hydrogen peroxide and then I'm simply adding a catalyst to it. I'm adding an enzyme that's found in yeast. And so the yeast isn't part of the chemical reaction. It just serves as a catalyst. And so what I can do is I can add hydrogen peroxide to it, seal it up, and I can give it a little bit of a shake. And what it's going to do is it's going to break down into water, and then it's going to break down into oxygen. And that oxygen is going to fill up the bag. Now, if you feel the bottom of the bag, it's going to get warmer and warmer. And the reason why is that we're releasing energy as we break those bonds and form new bonds to the point where it can eventually explode. And so sometimes you have to let a little bit of that gas go. That scared me.
Is that it?
Yeah.
Come together.
And that was the end of our presentation.
You're really making me work on this one. I'm telling you, you're making me work on this.